just stop and wonder how all those apps on your phone know who you are? And more importantly, what you're allowed to see and do? Well, today, we are pulling back the curtain on that very process. We're going to demystify how an application gets its own secure digital ID, so let's get right into it. I mean, really think about it for a second. Your music app can post to your social media, your calendar syncs up with your email, it all just works, right? But how does all of that happen securely? How do you prevent total chaos with apps grabbing data they're not supposed to? It honestly feels a bit like magic, but I promise you, it's a very, very deliberate system. You know, the easiest way to wrap your head around this whole thing is to think of a brand new app, like a new employee starting a job at a huge corporation. Before they can do literally anything, before they can even get into the building, they need an official ID badge. And that badge is everything. It proves who they are, and it spells out exactly what they have permission to do. All right, so let's follow this thing's journey from the very beginning. We're going to watch as a brand new app goes from being just a bunch of code on a developer's machine to becoming a real, trusted entity inside a secure digital world. The very first step is basically getting its birth certificate. A developer logs into an identity platform, think something like Microsoft Entra ID, and they officially register the app. They give it a name, let's just call our new app DemoApp, and boom. In that exact moment, the app officially exists in the eyes of the entire security system. Now, this is super important to understand. We're talking about trust here, but it is completely a one-way street. Our demo app has to put all of its trust in the identity platform to handle the security, to verify users, all of it. But the platform, it doesn't automatically trust the app back. Not at all. The platform is the source of truth. It's the security guard at the front desk. Our app is just the employee that it has to show its badge every single time. Okay, so our app has its ID badge. It exists. But right now, that badge is basically blank. So now we have to actually define the rules of the road for it, and more importantly, give it the keys it needs to get into the building and do its job. First thing we need is something called a redirect URI. Just think of this as a registered secure PO box for the app. When you log into the app, the identity platform needs a totally safe place to send that confirmation, that little security token that says, yep, this person is who they say they are. It won't just send that sensitive info anywhere. It's only going to send it to this pre-approved verified address. That's how you stop it from getting snatched in transit. Next, the app needs its own key, a way to prove its identity when there's no user around to log in. And it's got two main options here. A client secret is kind of like a simple password. It's super easy to use, which makes it great when you're just building and testing things. A certificate, though, that's like a high-tech encrypted key card. It's a bit more of a hassle to manage, but the security is way, way higher. And that's exactly why it's the gold standard for any real application that's out there in the world. So let's recap. Our app has an ID, and it's got a set of keys. But now for the big question, what can it actually do? What doors in the building can that ID badge actually open? This is where we get really specific about its powers. And these powers are defined by something called scopes. A scope is just a very, very specific, very granular permission. It's never something vague like access the employee database. No way. It's going to be something like permission to read the names and email addresses in the employee database. Each scope is a single, tiny rule that gets programmed right onto that digital ID badge. Let's break down a real-world example here. The scope is called Employees.Read.All. Now, look how specific this gets. If an IT admin is looking at this, the description they see is read-only access to employee records, all of them. But if a regular user is asked for their permission, the message they see is totally different. Read-only access to your employee records. I mean, how clever is that? It shows how a single scope can act differently depending on who is giving the okay. All right, now let's put two of these scopes side by side. Because when you see them together, it really highlights a critical difference in how permissions are handled, especially when there's risk involved. So on the left, we've got our old friend, Employees.Read.All. It's just reading data, which is a lower privileged action. So a normal user can look at that and say, yeah, okay, that's fine. But over on the right, we have Employees.Write.All. See that one little word, right? The ability to change or delete data? Whoa, that is a much higher privilege, much riskier operation. And because of that, only an administrator can grant that permission. The separation is like a fundamental pillar of modern digital security. So far, we've been really zoomed in on our one little demo app. But now, let's pull the camera back and look at the whole security picture. In a big company, who's managing all these apps? I mean, who has the power to create these digital ID badges in the first place? You gotta manage the managers. And this is where things get really cool, because you realize the system has to control not just what the apps are allowed to do, but also who's allowed to decide what the apps can do. It's this extra layer of security that sits on top of all the security we've already been talking about. This is all done through custom admin roles, and it's a perfect example of something called the principle of least privilege. It's a golden rule in security. You don't just give every IT person the master key to the whole building. Instead, you create a very specific role, like a credential manager, whose only job is to update an app's keys, but they have absolutely no power to create a new app or change its permissions. It's all about making sure everyone has just enough access to do their job and not an ounce more. So there you have it, this whole process, from the initial registration to getting the right keys, defining those super granular scopes, and even managing the admins themselves. All of it works together to transform a simple pile of code into a recognized, trusted, and fully governed entity in our incredibly complex digital world. It's how we create order from what could easily be chaos. And that brings us to a really fascinating and maybe slightly scary question for the future. We've just walked through this whole process for a pretty simple application, but as autonomous AI agents become more and more powerful, how are we going to apply these same principles to them? How do you give an AI its own digital ID badge? And maybe more importantly, what doors should we
In this lab, we'll go through register an application. So registering your application establish a trust relationship between your app and Microsoft Identity Platform. And the trust is unidirectional. So app trusts the Microsoft Identity Platform, not the other way around. I'll pass this GitHub link of Microsoft Learning so that you can follow when you do into your own environment. Uh, or your own setup. So this registering an apps has got first exercise is registering an applications where tasks involve like app registration, then configure platform settings. After that, add credential certificate and client secrets. And then we'll do add a scope. So scope is coming. You can see here like app registration section wise. So we'll do that part and add a scope recurring admin consent. And in exercise 2, we'll manage app registration with custom role. So we'll create a new custom role to grant access to manage app registration. So let's start the lab now. So very first thing for this lab, we need to connect to Microsoft Entra. So here I have already connected to Microsoft Entra. So now let's go to the app registration section. So here you can see under Entra ID, app registration, click on that menu or option. And then click on new registration, and here give a name. So let's give a name demo app. Then you can see that supported account type. So there are many options available. So in our case that is single tenant only contoso. And here you can see that redirect URI. So need to select a platform. In our case we are going to select that web platform, and it has got there. Then after that click on or select the, so we do not need to redirect URI. System picks up that one here, or you just click in this case, register an app you are working on here, integrated gallery app, the other apps from outside your organization by adding this form enterprise application. So these are the document that you can go through and read. Mm, And here is like by proceeding you agree the Microsoft platform policies. You can open that into policy to see the policies into a new page. So click on register. So when that get application completed, it actually directed to a demo app page. So in next task, we are going to configure platform settings. Settings for each application type, including redirect URI, configured in platform configuration in Azure portal. So for here, it is better to take that note like application ID. We may need this later on. So application ID. Other is tenant ID or directory ID. So tenant or city or directory ID. Let's just put a note of that one. Okay. Now, here, let me find that authentication options here. Other thing like when you do work actually, sometimes may see that all menu or options can be, some different place than what you see today because this cloud is always live and there is some like options can move here and there. So click that authentication options under manage section. And here you can see that uh, redirect URI configuration. So select that add a redirect URI, and then you can see that different options available here. So in our case lab, we are going to select web as our platform. And here we are going to redirect URI. So type that localhost for URI and then click on configure to complete the platform configurations. So successfully updated the demo API. Next task we are going to, you can see this one is here. So going to add credential, certificates and client secrets. So credentials are used by um, confidential client applications that access a web API. Examples of configure this some kind of client includes like web apps, other web API, and service type or daemon type applications. So this credential allow your application to authenticate as itself recurring, no interaction from a user at runtime. So for that, let's go to, you can see that certificates and secrets. Select that option and then click on new client secret. And we have to give a description and expire. So let's give a description. For this one, we're going to give SC-300. This is the course name of identity, lab secret. And duration, there is up to 730 also custom options available. So we are going to select for now 3 months and then click on add button. So we can see that secret has been created. We can take the value, secret value, also secret ID, secret value. And this is one time. So it is always better to copy that one. Otherwise you have to drop and recreate again. Now we are going to add a scope. So for that, when we are in this page, then you see that expose an API, select that option and here click on add a scope. So this has got directly application ID URI, and this is one here. So that is fine for me. Then save and continue. If you don't see value here, you can get that from their application ID URI. Now we are going to add a scope name. So let me first all this value, then I'll back here. So here under add a scope, who can consent for this one? I have selected admins and users. So for admin, I put that read-only access to employee records and allow the application for all employee records. And when that is user consent, that is employee records and to your employee records only. And then after that, use that state is select enabled and click on add a scope. So successfully added a scope. Optional that another task that to suppress prompting for consent by users of your app to the scopes you have defined. You can pre-authorize the client application to access your web API. So pre-authorized only those client applications that you trust, since your users would not have the opportunity to decline consent. So for that, you can see that authorized client application sections, click on add a client applications. Now here you can see that the client ID, we need to paste it here, and then we have to give authorized scope. So let me find the client ID, directory ID, application ID, tenant ID. Authorized scopes. Let's see if that works. So not this is the one. So I need this value, application ID. Okay, get this copied, then client application, paste it here. Client ID. Provide the application ID of the client application that you would like to authorize. This is the application ID. So application ID is not taking that value. Application ID. An application ID. Not sure why. Let me find that one. I think we have to remove this front part. Yep. So then click that authorize scopes and click on add application. So when you did this one, ultimately what it does, like the client app is now pre-authorized client app, which is PCA, and users should not be prompted for their consent when they are signing into it. In our next task, we are going to add a scope requiring admin consent. So for that, let's go back to like add a scope. Click that add a scope options. Then this time we are going only admin only. So give is like scope name. We're going to give employees dot write this time. And this time we are giving write access. So access to employee records. So allow the application to have write access to all employee details We are just admin, so we do not need for user entry here. Then click on, you see that is strategy enable, select add scope. So here we can see that we successfully added the scopes as per the lab it is mentioned. And when you do that one, you can see those scopes under expose and API section. And what you see that the URI and the option is that the scope we created. So employees.read.all, and which for admins and users, and write dot employees.write.all, which is for admins only. So in next exercise, we are going to do manage app registration with a custom role. So for that, let me close this one now. When we are in Microsoft Entra Admin Center, select the roles and admins options under Entra ID or menu. Select that one. And here, let's create a custom role. So for that, select new custom role. Give a custom role name. You can see the different other options available. We are taking all the default value. Select next. Like you can start from scratch, you can also clone from a custom role. So if you have another custom role, you can select that one. You will get an option to select that role, but we did not create here yet. So then there is a next page. You can see that permissions. So give a name like permission. Or this is the first page. Just remove because I select that one. The name, description. Start from scratch. Click next. So here you can see different permissions available, and you can see those descriptions for that permission. So let's search for credential. So we are going to select a manage password single sign-on credential on service principal. So select that option. Another one, manage application provisioning secret and credential. So for our lab, we need to select these two. Read password single sign-on. No. So manage password single sign-on credential on service principal and manage application provisioning secrets and credential. So click next option. And why we pick these two actually? For application provisioning, these two items are the bare minimum permission needed to enable and enforce single sign-on for the applications or service principal that is created. Therefore, we selected this one here. Then click create button. So you can see that a role has been created. So role is there. Now if we want, we can just add assignment for eligible assignment, also for after whenever we needed, we can also add that active assignment or expired assignment. But for our lab perspective, we have finished our lab. That's all for this lab. If you have any questions, add that into comment section. Otherwise, I'll see you into next lab.